Welcome back. Today we're going to talk about the spatial visualization and multi-view drawing, chapter 5. As you can look at this perspective projection example, viewing an object by eyes create a depth distortion. This phenomenon is recreated in a field of drawing called perspective projection. And this distortion occurs because the visual rays used to create the image in the viewer eyes are not parallel. This distortion, while useful in providing the illusion of distance, result in a loss of image accuracy and fail to provide the information needed for most detailed technical communication. In order to develop multi-view drawing, you must be proficient in the concept of spatial visualization. That means when you look at your eyes, when eyes looking at any object through an edge of projection plane, you're never going to get the true size and the true shape of the original object. What is a spatial visualization? We see the world in three dimensions. When we look at an object, it has a height, length, and depth, meaning you have X, Y, and Z. But when working in engineering or drafting, or sometimes have a communicate our idea in two-dimensional format, making two-dimensional representation of three-dimensional object, or looking at the two-dimensional representation and visualizing the object in three dimensions require a scale known as spatial visualization. So to make it short, making two-dimensional representation of three-dimensional object, or you want to go the other way around, meaning you're going to look at three-dimensional object and then making a two-dimensional representation. This is what we so-call a spatial visualization. Now let's look at one of the example here, two-dimensional spatial visualization. Let's say if you take a three-dimensional, take out any book, and this book here happen to be this textbooks here, and if you put them at the um, exactly at the perpendicular to the front cover, you should see no depth. But then at the on the other hand, if you twist it with the angle and place it this way, you're gonna see the depth and the height and the length and so on and so forth. But if you put them perpendicular and at the very flat surface, you can see uh, 6 total views, and this view we call orthographic views of the book. And the orthographic view, you're gonna see the front view, the top view, and the bottom view. That's 3 view. Right view, side view, and the back view, and that's the 3 more views combined, 6 views total. So this is what the back of the book, the front of the book, you're gonna see this is the front of the book as I show you right now. This is the front of the book, and then you got the top of the book, and then at the bottom of the book, right side looking at this direction, your right side view, left side view, and the back of the book. So your back of the book is, what is the back of the book? You're looking at this direction, and that's how you see the back of the book. Now let's go to next slides. And so three-dimensional spatial visualization. So we got three-dimensional view of an object. As you can see from here, this is a three-dimensional view. But then, of course, always you can create multi-view of this object. And this visualization, what a three-dimensional object will look like when drawn in two dimensions, is half of the spatial visualization challenge. The other half involves using a two-dimensional representation of an object as the basis for visualizing what the actual object will look like in three dimensions. So for example, look at the two-dimensional drawing. How would this object look in three dimensions? So you're gonna have to ask this question. How would you look if you have this back, you have left, you have front, top, bottom, right side? How would you visualize this 6 view into three-dimensional view. So that's the techniques that we're going to learn for this chapter. And of course, nowadays we have all this different software, and you can use AutoCAD, use a solid modeling software where this software can generate, some spatial visualization and make everybody's life a lot simpler by doing this work. And you don't even have to worry about uh, visualize you know, visualizing any object. And consequent, so it doesn't matter. Sometimes it's even harder to visualize an object. Even the software, they can't do a good job. So what you're gonna have to do is very important that you develop this skill so that you can use any software in the future. That way you can apply the spatial visualization manually. But most important thing is that you're gonna have to know the techniques. Think with your brain and then transfer your idea into your CAD. Visualization and multi-view. And now we're going to talk about the orthographic projection is drawn by representing an object by viewing it perpendicularly through an imaginary projection plane. And orthographic projection is the most accurate term for shape description, when an undistorted image of the object appears in a flat, transparent, but imaginary projection plane. Let's go a little bit more in that detail. What does exactly the orthographic projection mean to you? And as you can see, here the projection plane, and this is your object, and this is your edge of the projection plane. As you can see, if you project everything here, as you can see, this point projected horizontally going through, and then keep going. And maybe I should turn that into a different color. And okay, so I won't be able to change any color right now, but okay, let's keep them the same way. Let's go back. And so what it is that now you continue to project this point to your edge of projection plane. This is the direction of viewing. As you can see, all this point, when you transfer all this point on after this edge of the projection plane, your object, and it's gonna be a different rotation. So as you can see, the object from the projection plane, when you project them into this edge of projection plane, and your object is gonna be a little bit different. So look at another view here, and if you look at this projection plane and your front view, once you project them parallel from this point to that point, so all this point project to that point, all this point project to that point, you can see this front view, you can see all this here, little L shape and a square shape. And is that a true shape? No, because looks like a true shape, but it's not a true shape. And how do you make a true shape? Then you're gonna have to viewing the plane, provide actual size and shape of the surface. Then you're gonna have to project another view to get the true size and the true shape of an object. So same thing applies to this situation where you have a object here, and you're gonna project them to an edge of projection plane, and then after you project them, and you can transfer them onto another another object. So so this is a good example of how the projection plane looks like. And if we're gonna continue to the next example here, and let me clean everything up. And here, as you can see, surfaces. Normal surface show the surface as true size and shape. Foreshortening is when the length of the edges are shorter in the image than in the actual object. Inclined surfaces are not parallel to any principal viewing plane. So what is all this normal foreshortening and the inclined surface? Let's look at the simple one, the view object, such as a carnivore. It needs only one view to describe the true size and shape. An object such as the flat gasket, and as you can see from the bottom of this view drawing, and you can see this gasket here. We don't need so many views to represent that object here. And for the gasket, we just need one view, and then all you have to do is show the thickness of that object, and you're done. You don't even have to show this top view and the bottom view. And I mean, it's okay to show it, but you don't need it. I mean, it's ways to create so many views and could confuse the audience. So I would just, for this case, if this is the top to bottom, the same view, don't show so many view. And if the top and the side view is the same view, don't show it. Just show how thick that object's going to be, and you're done. For this particular case, your carnivore is a little bit different. The sphere doesn't matter what corner, what location you're going to be looking at, they only show as a circle. As you can see from here, one view drawing is absolutely enough. If you look at the let's look at the orthographic view. Front view referred to as front elevation. Right side view referred to as right profile. Top view drawn to ensure adequate representation of object. The front and the side are beside each other and have the bottom aligned. Okay, I'm going to stop right here, and then we're going to continue on to video 2 and talk more about the orthographic view.